Hello, today we'll be talking about the aldol condensation here. This is an exciting reaction where we start using that enolate chemistry we've been talking so much about, right? You're probably bored talking about enolate. You want to let's just use some enolates, right? Let's do some chemistry. And that's what we're going to do today. We're going to take enolate. We'll use a aldehyde here. We're going to do this under basic conditions, NaOH, water, and heat. We generally do these under heat to get the reaction to go. And what we're going to form here is something kind of interesting here. We're going to form this species here. Not only do we have our carbonyl here, look at here, we made a double bond here. This is going to be our alpha beta unsaturated carbonyl, right? Our alpha beta unsaturated carbonyl, right? These are pretty interesting molecules in terms of the alpha beta. Alpha, and this is the beta, alpha beta unsaturated next to that carbonyl here, right? This really has that conjugation in because we move this double bond over here. We can see that this double bond is kind of talking to this carbonyl as well, right? But through resonance here, okay? Interacting with each other through resonance here. And so to do this reaction, we'll go through the mechanism of this, is we're going to use our base here. We use our base to deprotonate this hydrogen here at the alpha carbon to generate our enolate. The enolate's just going to attack itself, right? We're going to attack itself. Remember we talked about this idea that as we do this reaction, this OH here isn't going to be a very strong base to pull off this proton here, right? We're going to pull off a little bit of this, but we're going to have a lot of this starting material left around that we can then react with itself, okay? It can react with itself. So let's go through that mechanism and how we can do this. Let's go through a couple steps. This is about a two-step process for this mechanism here, for our aldol condensation. All right. Enough talking. Let's do move some electrons around, right? So we're going to start with our carbonyl here and our NaOH. Again, we're going to pull off this proton here. And remember, this is going to be in our equilibrium. All right. So we've made our enolate here, right? Our enolate is going to be in equilibrium. As we pull off this proton, we're going to generate some of this product. Some of this product here is then going to go ahead and react with what? This same carbonyl. So let's draw that out. Remember, during the reaction, we're not going to make all this isn't going to convert into enolate. We're going to make a little bit of enolate, but still have a lot of this starting material left behind that we can react with, right? Now we're going to take our electrons here. These electrons are going to attack. Where are these electrons going to attack? Where is our electrophilic carbon in this molecule? Which one is it? As we saw before with our other reactions, we're going to attack that carbon there, all right? Just like we saw before. Attack that carbon there, electrons move up, okay? So let's draw this over here. We're going to draw in our hydrogen here. Now this is the part we have to be careful here, right? Make sure we keep track of all our carbons here, okay? This is going to be our carbon here, and this carbon here, these two carbons. Carbon 1, carbon 2. So this carbon here, we'll call that carbon A for alpha carbon, A. That's our A carbon. It's going to attack carbon 1, which is going to have our oxygen attached, and then carbon 2. So that's 1, that's carbon 2, okay? So at the end of the day, we have 1, 2, 3, 4. 1, 2, 3, 4. We have all our carbons there. We need to keep track of our carbons. It's really important. Keep track of your carbons. We don't lose a carbon. We don't want to add a carbon. Okay? We want to keep track of everything. So we have all our carbons here. Negative charge here. Let's take care of that negative charge, right? As we always do. This will then take off the proton. And we're going to get to this species right here. All right. So you think, well, are we done? We're not done yet because this compound here under our basic conditions under heat isn't very stable, not stable. Okay, it's not stable. Also, I promised you that we're going to form our alpha beta unsaturated carbonyl. And this is definitely not an alpha beta unsaturated carbonyl, right? So we got one more step to do. This isn't very stable, right? It's not very stable under our conditions. So what's going to happen is that we want to form the more stable compound, which again will be our alpha beta unsaturated carbonyl. Why is that more stable? Because of that conjugation between the double bond and the carbonyl, okay? That's going to help it be a lot more stable. remember we have this under basic conditions. This is going to take a proton here. And as we do that, we're actually going to bring the electrons here, and we're going to kick off that OH group here, okay? This is doing a somewhat of a type of elimination, where we're going to pull off this hydrogen here. Electrons collapse and make that pi bond. We're going to kick off that OH group, okay? That's going to give us our final compound. That's going to end up giving us our alpha beta unsaturated carbonyl, right? We've made our new compound here, okay? So as we did this reaction, we pulled off the proton using our base, generate enolate. Enolate then attacked our carbonyl. Remember, we kept track of all our carbons, right? We won't lose any carbons. So this enolate attacked that carbonyl to generate our species right here, okay? Then we protonated our oxygen. Then we generated this beta hydroxy carbonyl. But again, that's not very stable, right? This is going to be more stable. This compound here is more stable. All right? Again, it's more stable because we have this double bond here adjacent to our carbonyl. It has that conjugation in it, right? We talked about conjugation before, remember? When conjugation is good, it makes things more stable because electrons are more spread out, right? Electrons are shared more sharing, right? And so we have this more stable compound. That's the driving force to make this compound here, which is going to be more stable, our alpha beta unsaturated carbonyl. Notice all our aldol condensations and things, we'll see a lot of alpha beta unsaturated carbonyls, okay? So this is our adventure in aldol condensation here. We used an aldehyde here. Notice we used an aldehyde. It was great because we only had one alpha carbon to worry about, right? In other videos, we'll start talking about this idea of what if we have multiple alpha carbons? What's going to happen, right? What could go right? What could go wrong, right? We'll see that, okay? So this is our alpha beta unsaturated carbonyl mechanism and reaction.